Yeah, that's true. That's true. Catch Southwest. You said they canceled like another 300 or some odd flights the other day. I think they go everywhere now. Yeah, they have hubs. I think Colorado's one of their hubs, but they have direct flights from here to LA, like one day a week. Yeah, but the I don't know, it's these weather, they keep having weather issues in Florida that's causing them to like cancel hundreds and hundreds of flights. Like it's insane what it must be costing them. You got people like me that'll go and complain and just get hundreds of dollars in free flights. I mean, that last trip, I mean, I got a full refund in points for my flight plus another $1,200. I know. Yeah. I'm not encouraging this, but one of my consulting businesses is with travel hacking, so I know quite a bit about that stuff. And the way it works, if you're booking flights with points, is you can typically cancel the flight up to like 5 minutes before it takes off. I mean, I'm not encouraging this ethically, but you could book flights with points, sit around, hope it gets canceled, so that you can then put in a request for, and actually, I think they might even send like automatic their love vouchers. Yeah. You could probably just start collecting love vouchers from canceled flights. And if your flight doesn't get canceled, just cancel it yourself 5 minutes before for a full point refund. Man, that's bad.
That's terrible.
At some point, they must have a system that has to like flag if this person's like canceling flights constantly, they get put on some list.
Yeah. I prefer not to blacklist.
No, I think they share lists. Yeah. Because all those folks that like when they're not wearing the masks on the plane, they make the big deal and they get hauled off. They get blocked on all airlines, or at least all like domestic airlines or something like that. Wouldn't that suck? Like all of a sudden it's no longer an option to fly. You just yeah, you're like hiring some dude from your church who has like the single engine. He also mows the lawn there. Yeah, that's a lot easier said than done. No, not for the reason you think, because I looked into doing it, and so I can afford the plane part of it, but I don't fit in any of the planes they use to train you. Those, how many of you have ever been in one of those single engine or even dual engine? They are tight. There's no room in there for like a normal person. So I did go to a place and they were going to put me, they have like a 4-seater. And, and they could push the seats way back, and then the instructor could sit in the back seat. And technically we could make it work. I mean, it was still a tight squeeze. And like my back would have to be in like really good shape that day for me to do the contortions to get in. Yeah. Yeah, I see well this way. I can't read my keys here.
Because I know a lot of people that want to fly, they get like.
Well, I mean, I think you wouldn't like get into the Air Force.
Yeah.
They're not going to let me go up in an F-15 like I'd fit in that. I'm more one of the cargo aircraft pilots. Yeah, I mean, you need to have you have to have good vision to fly in the military, but I think you can be like a commercial pilot with corrected 20/20 vision. I've seen plenty of guys flying 747s who have glasses on. So I think you just have to have corrected vision. You have asthma? Doesn't that just mean out of shape? Like exercise induced asthma means like, okay, I go run, I get like really, really, really winded. And like, no, now I have asthma. How'd you get it? I was exercising. I'm just, hey, look, I'm just calling balls and strikes. Hey, I believe you. So does that mean because I start doing any sort of exercise, I start wheezing and all this stuff. It's not good. So don't exercise.
So, I'm not gonna lie, I bet
He used to be a D1 athlete.
Who, me?
yeah.
I used to play Division I tennis and then broke my back. I was ripped. I know. Well, actually, I don't know if I'd ever say I was ripped, but I was like good shape. I was 6'5", 230. I played tennis at. Now I'm 6'4" and a half, 400. Well, I'm like 387 this week. Yeah, because I'm on my diet that lets me drink wine. All I eat now is chili and wine. It's like the best diet ever. Oh, I drink a lot of red wine. But like this is a real diet. There's this guy who's like a body hacker, and he wrote the book called The 4-Hour Work Week. It's like a kind of a famous book. And then he wrote another book called The 4-Hour Body. This is from like 10 years ago. So some people call it the slow carb diet. So it's kind of like a low carb type thing, similar to keto, but like you can have beans and stuff on it. It's like the ideal meal is literally chili, but you can't have cheese, even though that's low carb, something with the dairy, the glycemic index. I don't know, he does all these tests and stuff. And like the secret sauce is within the first 30 minutes of waking up, you have to have 30 grams of protein. So you take like a protein shake or something. Yeah. Yeah. So what I do is I just, I pour about a quart of wine into the blender and I just load it up with protein powder. I get it nice and frothy. No, you're allowed to have 2 glasses of red wine per day on it. So that had to, yeah. And they also they don't get that specific about what's the size of a glass. I wish I stopped there.
At this point, we'll now have a back a lip and brain.
Yeah. All right, let's start talking chat server. Shut up.
No.
Remember the trains on the track scenario from earlier? All right, let's see where we left it off. We have our server, our client. So let me just see where I left us off here. Okay. Have them talk to each other. When we type something, have it echo to everybody else. Okay. So, and I already have it up in a repository, right? Repos.
Why'd you bring Unity as a 250?
Why not?
Oh my gosh, it's so annoying. Don't get me started.
Isn't that good?
We never had that.
Well, they're better than you. Hey, look, he called my code disgusting. You had that comment. As things are moving towards a lot of VR stuff, in my view, I think having Unity as a skill set might be a little bit more valuable than having native Android as a skill set right now.
I think it's also good for a freshman to get into a senior project.
Yeah, I think it's fair. Really?
People are having issues.
Well, is it because you don't know Unity?
Yeah.
Oh.
I don't feel like learning it right now.
I think he has some advice for you. Suck less. All right.
Sorry.
Sorry, I got very confused. All right, so let me just run this real quick. I do pretty much recall. So what is that called? Chats. Oh,
Run chat server. That's your script.
yeah, and that compiles it and everything. All right, so it's listening for connections. Then I can have multiple clients try to connect, right? Yeah. Repos. All right, so all right. Oh, I have a run chat client too. There we go. Now let me get multiple connected. Okay, so I have multiple guys connected to the same server. And I started typing the name here and he just echoes to the server, right? And then he disconnects. And then the server, he disconnects. So the client is finishing his job. All right, so what we're adding to this, server's still staying alive, listening for connections. The worker bees on the server, let's go look at the server code here real quick. Here's our worker thread. Worker thread sits there in his run method. Oop, Ninja. He asks their name, reads it in, prints it out, dies. So that's what the threads do right now. All right, so I think so what we want to do is we want to have the clients persist in their connection. So we want to keep asking them, keep waiting for them to type something, and then have it so that all of the, when a client types something, it then gets distributed to all of the other clients to write stuff out, right? That's the deal here. All right, so I suggested that maybe what we do, I probably mentioned something about thread safety at some point. Did I say that word? Okay. We'll talk about that today too. So I'm going to go ahead and create a new file. Is this how I do it? This guy, Ninja. Command N. Oh. All right, so, well, these are stupid. These editors are dumb. All right, so we're using Java, right? Okay. So I'm going to go ahead and I'm going to create a class called core.java. And I just happen to like calling these my singletons cores. If you remember from 250, we would have talked about the design patterns. So design patterns are this, the idea that a proposed good idea for solving a common problem, whatever that means. One of the things that we looked at is MVC, model view controller. So that says it's a good idea to keep your data separated from your logic, separated from your interface. Well, we don't really have an interface here, but in any case, that's one design pattern that's kind of famous. Another one is a singleton design pattern. Singleton design pattern says it's a good idea to keep stuff that needs to be shared across, we can call it more than one class, but maybe it's better to say more than two classes, in a centralized place. All right, so we put it in one place so that they all have access to it, as opposed to passing things back and forth. And we looked at this, I think all of you, when you had 250, that's when we did Android. So we looked at the difference between writing a singleton and also like the put extras, right? When you you hide it in the intent when you're getting ready to launch the next activity, kind of stick it in there, and then you extract it on the other end and that stuff. But in this case, if you want to have something shared among all of them, we can put it in a central place. So what I'm going to do here is I'm going to create an array list. All right, so I'll create an array list, and let's see, what do I want to make my array list of? So, I mean, we have options here. I can basically say, well, every single time a new client connects, we can just actually put the socket, the living socket to that client up in this array list. But really, if we think about what's the job we're actually trying to accomplish here, the job is we want to be able to print to all the other clients. So we really want to have an array list of print streams, right? Every single worker thread is going to generate a print stream to be able to write out to the client. So if they already have a print stream, can't they just go ahead and say, here, there's the print stream to talk to my guy. Go ahead and store a pointer to it so that if you need to talk to my guy, you can. Makes reasonable sense. So we're going to say this guy is a array list of print streams. We're going to call this the client streams. All right, and this will be a new, what did I click here? Clear, where, there? New array list. I don't think this is actually necessary on the other side there, but I like to write it like that. All right, so we're going to have this thing. Now, what we're going to do is I'm going to make this static. I think I probably brought it up in the 250 class when we first looked at singletons that built into a lot of Java IDEs, and certainly was that way with Android Studio. I don't know if it still is, but they have a thing where you can create a singleton and it generates a class for you. And the way they like you to make a singleton is to request from the singleton the running instance. And then you use that instance to call a bunch of instance members. So the only thing that would be static inside the singleton would be the instance of that particular singleton. I know that just seems stupid to me. So why not just make everything in there a class member, class methods, class fields? Maybe under the hood, there's some sort of performance thing on where these things are stored. Yeah, I haven't looked at it that closely, but I can't imagine it's something drastic in terms of performance. So anyways, now I have this guy right here. So from a chat server perspective, I'm sorry, from a worker bee perspective, when a worker bee is born, he's going to create his client output, right? And the very first thing I'm going to do is I'm going to add, and actually, if I want to make it a little bit more obvious, I could make this guy a private static, the client streams, and then I can make a public static add client thread print stream. I have this guy taking a print stream PS. And this is actually going to be the way we want to do it anyways, which we'll talk about today for the thread safe side of things. So then I'll say the client streams dot add PS. And this guy returns nothing. All right, so I have a static method, but this guy is public. So this static method can be called by my thread. My thread will pass him the print stream for his connected client, and this guy will just add that print stream to the static member of the core class. So you could say core dot that. I kind of prefer that, but since we're coming from a static context here, he has access to that directly. All right, so now when we are on the worker thread, whenever we create that client output print stream, we can go ahead and call core add client thread print stream, and we can add this dot client output. So effectively, we're just giving that singleton a pointer to our created print stream. Make sense? All right. So up in core here, I'm also going to go ahead and create a public static void broadcast message. We'll just keep it as message now. We can clean it up later if we want to say, you know, Mike said this and Dave said this, whatever, but we'll just have it spit out right now. So what this guy is going to do is he's going to go ahead and iterate across all of the print streams. So this is for print stream PS. Is it not four? Is it for each? No, for each doesn't exist.
Or it's four type bar in parentheses.
Well, this guy has that parentheses.
Yep. And delete that last one. After the client share.
Oh, that's part of the syntax. It's parentheses like that. Okay. So this will create actually, this doesn't technically create an iterator across it, but there's something else called an iterator, and I'll bring that up when we talk about thread safe too. But this is going to give us a print stream for each thing that's in here, and we'll go ahead and say ps.println, whatever the message was. So when we call upon our singleton to broadcast the message to everybody, it's just going to go through all of its stored print streams and print out to each one. So then on our worker thread thing, instead of name right now, let's just actually we'll still read in their name. We'll broadcast message. That we've joined. And then we'll just do a infinite loop for right now. I'll actually create my message before that, then just use it. That way we're not redefining every time through. It's allowed, and it probably will actually make it work the way I just wrote that. So we'll read in a message from a client, and then we'll broadcast whatever that message is to all other clients. Okay. This should give us what we're looking for, where our client won't give us a prompt or anything. We can make it give us a prompt, but that's going to, as soon as we broadcast, your prompt is going to be 20 lines up. So we'll just have it sit there waiting. Back out here, I'll go ahead and kill the server. We'll run our chat server again. We'll connect with a couple of these guys. I'll say Mike. Oh, I didn't, I need to, just my run chat client, not, oh, the client isn't, I didn't fix my client yet. Yes. Okay, so my client, we want to read in multiple things. So right now I'm reading in from my the server here. So we'll just throw this inside of a while true. We'll have to give it some way to exit out later. All right, so Dave just joined. Mike probably became aware of. Did he not become aware? Isn't it broadcasting? It is compiling. It's listening, incoming connection. That guy's still waiting because our client is in an infinite loop. Make sure this is getting called by. We might need to do something called flush. Just want to make sure this is getting called. We are adding the client. Whatever, something like that. That takes the output stream of a socket and clears out the bytes that are currently in it. I would think that next line should do that. There's probably a way of creating a print stream with or without what's called auto flush. Yeah.
Do you think that the problem that's happening right now is that the core is trying to send a message to a client, but the client is waiting?
Our client should be waiting for, well, our client's actually, you're right, the client's never actually reading. But then if that was the case, we broadcast to a client. It's coming from another thread. The client here is waiting to read something in to send to the client output. But while it's doing that, why can't it display something that is printing out? I don't think so. This blocks here, yes, but this client side is not the guy using Core. And Core has access to the print stream, which should be able to write out to that, that client. I mean, what you're saying is while I'm sitting there and it's waiting for me to type something in, that client in that particular thread can't do anything. But the terminal, just like we saw back here with our running server, actually, I think we stopped doing it, but it's writing stuff out here to the terminal, even though the server's back listening. It's the threads that are writing stuff out. So, I mean, it's possible you're right. We'll look at it here in a second, but the concept would be if he's the server and I'm the client thread and, you know, it's waiting for me to type in my next message and he happens to broadcast something to all the client threads, including myself, my output stream should be directly linked to my screen on my computer, not going through the client. It's possible we might have to spawn a thread to have the client sit there. I mean, so we can fix it even if that is the problem. We can spawn a thread on the client for the client to sit there and listen to, you know, what's the next thing the client wants to type in, leaving that original thread available for broadcasting. But I wouldn't think it would block that way. So let's see here, making sure I'm getting into my various functions just for sanity's sake. So we should see out here. So our chat worker thread, where did I store? So I don't see these actually writing out. Here's my chat server. It's listening for a connection. It connects, spawns off a worker thread. Here's my chat server worker. No, yeah. Here's the worker. It broadcasts a message, but when this chat thread was first created, we should have added a client thread to the print stream. So that means when this thread was first created with that socket, before it asked us for our name, we should see written out to the screen, adding client thread. That should happen right away. Go ahead.
Okay. Maybe I'm a little confused. Shouldn't people continue to input streams and not their output streams?
Yeah, their output stream, the output stream of the socket is what we would write stuff out to for the client to receive.
Gotcha.
So if I'm the connected client and he wrote something over the output stream of the socket, that would be something that I would then get. But based on what you're saying, and actually that is right. I'm using the print stream to write to the output stream, but the output stream is never being read from and then broadcast back to the screen. So we're actually going to need, at least we're going to need an extra thread on the client for the client to constantly be listening for a message, read it in, write it out, read it in, write it out on a constant loop. So he's prepared for a broadcast message. Because what's happening now is we probably are broadcasting, but nobody's on the receiving end to get it. That still doesn't explain, though, here on the chat server side, why I'm not seeing when we add a client thread print stream here from core, this should be writing something out to the it should say adding client thread as soon as there's an incoming connection. And so let's make sure that's happening, and then we'll go add the second thread over on the client side, which will be not a major deal thread. All right, so as soon as I connect here with the chat client, why am I not seeing it right out? Because this function is being called. So about to add a print stream. This could be a thread safe thing. About to add a print stream. Let's see if that at least displays. That's happening at the top level of my thread. Adding client thread showed up. And that is, oh. Was that not showing up? Was that showing up before? I just didn't see it. I'll connect with the next one. Adding client thread. We have the about to add a print stream, adding client thread, about to add a print stream, adding client thread. That actually could be kind of interesting if I take out the about to add. Then we go and run the server again. No, whatever. Okay. So I'm going to show you an interesting thing that we can do, at least in the short run. So we're going to do Java thread here, because what we need to do is on the client side, we want to have a thread that all that guy does is sits there and tries to read in from his input stream. That's all he does all day long in a separate thread. And we need to have it in a separate thread because that blocks. And the reason I want to show it to you is right now, the way we've done threads is we actually created a separate class that extends a thread. And why did we do that? It's because, oh, well, we needed the socket connection and we needed all this extra stuff that we wanted to keep track of. Well, in this case, I want my client to spawn off another thread that already has some of these things available. I'm pretty sure scope wise, this will be fine. Huh? No, thread already implements runnable. But what we are going to do, I'm sure they're gonna have a example here, is you can create a thread. So for instance, in the client, here's in my chat client, right before I sit here and do this forever, I can go ahead and say, let's call this guy thread listener thread LT is equal to a new thread. And then I can override the run method right in here. This has to have a semicolon at the end of it. So rather than going and creating a whole new class, I can inline my override, my run method that I want to have for this guy. So inside here, I'll just say while true. And what we want to do is we want to read in from our client input. So client input is our scanner. Next line. And then system.out.println, whatever we read it. So that's what this thread will do all day long. Read something in, spit it out to the screen, try to read something in again. Good.
When you read in next line, does it like move on to the next line? Or it's just gonna print hopefully.
No, because next line blocks. It blocks until there is something available on that input stream. So the real question is going to be, well, what if we have multiple things come into the input stream? This will get to our conversation about things being thread safe. It will, I'm pretty confident it's going to work fine, but we might be able to force it to sometimes miss a message if we bombard it with a whole bunch of stuff. So all this did is create an instance of my thread, but instead of having a whole nother class, I was able to embed my run method inside here. So I just said, hey, this is a plain Jane thread. I'm just going to make this guy work here. And I'll tell my thread to start. So kind of a convenient way of creating kind of a quick thread that just does a little task rather than creating a whole nother class. I maybe would say creating a whole nother class is still probably better, especially if we consider we might want to do some extra stuff in here to maybe make it look nicer, whether or not it was a message sent from us, or, like the difference between, you say something versus, Carl said, Mike said, Dave said, something like that. All right, so let's see how that guy is looking now, since we're going to have our client pop up. He's going to be waiting for our client to type something in, but he's also going to have a thread that's going to constantly be listening, reading something in from the print stream that's on the other end, and then just spitting it out, echoing anything he gets out to the screen. All right, so we have multiple connected guys now. We'll type in Mike here. He gets broadcast to himself that Mike has joined. The other guy will not have. Oh, he did, because he did add himself before he typed that. Although that is interesting. Why did we get Mike has joined? When did we say that from the threads perspective? Oh, that is after we had added it and after we read in the name. So since we didn't broadcast to everybody, both clients had connected. And at that point, once they've connected, both of those clients had added their print stream to to Core's collection of print streams. Then I actually typed in the names on each client, where the client was waiting for me to read in my name. This line blocks. I read it in. We then broadcast that message to all connected print streams. And at this point, both guys had their print stream connected. And then I'm just sitting there waiting for them to have back and forth banter. So now from these clients, I should be able to type something in. Interesting. LOL has. Oh, I did. That was my name. Thank you. So I'll broadcast LOL. Here's the LOL. Woot. The Woot broadcast back to me, because I'm one of the print streams that's connected to the server. And then here's Woot over here. So now we have back and forth between all of those guys with very little information about who is sending these messages and things like that. But we are having them all broadcast. Now we could possibly force it. Well, let's talk about thread safety at this point. So I guess that technically probably fulfills the assignment. That seem reasonable. All right, so let me just do this real quick. Let me kill these. Let me upload this current version of the code. And actually, before I do that, I do want to go into my chat client here. This guy right here is kind of a pretty important thing. It's what if you were to give an official name for something like this, it's called a closure. So this piece after this is a closure, where we are augmenting an existing class by overriding something, but we're doing it locally. So you'll maybe commonly see examples that are like this, where instead of having a whole nother class, where we create something that extends thread, write our own run method that overrides the thing, we can do it right here. I guess during runtime. I still would argue this isn't great programming practice all the time. You want to consider whether this makes sense, but because we're doing something very simple, you might also say, does it make sense for us to create a whole nother class just to do this, where we're going to have to pass that guy a pointer to our client input and all that stuff, when we could just deal with it right here? Because notice that this thread is able to share the scope of what we have right here. Does that make sense? In fact, actually, from Java's perspective, this guy's not being used. Oh, no, he's actually just saying we never closed that. Nah. Go ahead.
You can do it with any class, or it's like,
Yeah,
special.
you can do it with any class.
Classes and things like
Oh, sure.
that. Okay.
Yeah. In fact, let me try to show that. Let me push this real quick, make sure everything's saved. Because it's an interesting thing. You can break your own code
With doing that.
with doing that. So you can write your own class that has a do something method. And by default, the do something method does something. You can then create an instance of the class that changes your do something method to do something else.
Like, the weird thing about that is looking for like tax and stuff, I can just go.
You'd still have to know what's going on the inside.
Right.
Let me push this real quick before I forget, and I'll take your question, and then we'll look at an example of that. That's not the thing. Working broadcast. LOL. Push origin. All right, so that guy is up there. Okay, what's up?
Can you add methods to a class like this? Or can you just-
I would think you can add methods. I don't think they'll keep you from doing that. Yeah, I don't see any reason why you can't. Yeah, we just never use it. There's nothing wrong with, yeah, I just created it. So now LT has a made up method. Yeah. We're just calling the method that never does anything. Yeah, it's kind of interesting. So that would be handy. Let's say that you want to do something special with strings. You could add a method to a string when you create a string, like string s is equal to new string woot. Do I already have an s somewhere? So then we should be able to say my string dot made up it should print something out. So we just made strings, I don't know, better, different. Oh, for strings, we can't because string is defined as a final class. So when a class is considered final, it cannot be modified further. You would have to extend string yourself. Actually, you would not be able to extend string if it's final. You'd have to have something that just creates an internal string and then does your extra stuff. So that's why this guy isn't happy. Let me take the string thing out. But for your own classes, the syntax should work. as long as you don't make it final. Thread is not going to be final because we can't extend thread. So can't find made up method. Put something in there just in case it doesn't create it if you don't do anything. Yeah, maybe you can't. There is another mechanism for creating it's not called generics, it's called C# definitely has it. Be surprised if Java doesn't. Java add method to existing class. Well, if I make it private, then it's you won't be able to access it. Oh, here, let me show you the C# one first, and then we can maybe backtrack it to the extension method. That's not it. It's called extensions. The original thing is called class geek. Oh, it's using just a special syntax for what it gets passed in. Yeah, there's definitely a way of doing it. It looks like it might be a little bit hacky, where you might just create a secondary class. So it looks like this syntax will only let you override existing methods, even though it's not complaining here, because the original thread class did not have a made up method. I wasn't overriding something. So when I get to here, it can't find that symbol because it's operating off of what the thread class has, not what I've modified on the thread class. So you can't add new methods, but you can update old methods, make them do extra stuff. Seems reasonable enough, I guess. Out, we'll leave the okay. So let's talk about thread safe. And I'm pretty sure array list is not thread safe, which is why I suggested you use that. So thread safe is when probably a class is written such that it handles multiple threads calling it at, I'm just going to say roughly the same time, effectively solving the race condition problem that we use semaphores for in multi-process communication. Yeah, so an array list, so in Java, now we actually can fix this real easily for us. Let's talk about the side effect here. The side effect here for us, it might be difficult for us to actually create enough clients where we can create the issue where clients are actually connecting at the exact same time, because every single time a client connects and we spawn off a new worker thread, and that worker thread adds that client's print stream to core. If we have 1,000 clients all roughly connecting at the same time, there is a decent chance that 2 or more of those clients will try to call this method at the identical time, which then causes a problem. If they both call it at the identical time, we would call this roughly the critical section from what we talked about previously, right? This would be our critical section that we protected with a semaphore. Then they're both getting that array list, and it's possible that when they update the array list, they're overwriting each other, and only one of them ends up being there. And that's because the array list's add function is not thread safe, because it has not been what's called synchronized. We can fix this by just making our add client thread print stream synchronized. Pretty nice solution in Java, where you just say, look, make sure more than one dude doesn't call this at the same time. And it just handles the magic for us. It has a built-in queue. So anybody who's trying to call it at the same time will hit the queue, and it'll make sure they ultimately can get to call it. So this should still work the way it worked before, seemingly. Okay, still working the way it worked before. We could just start typing back and forth. Doesn't matter if we're on the same computer or not. Okay. So where does this have the biggest impact? Perhaps for us, it's going to have the biggest impact on our broadcast. Now, as we have it right now, a client doesn't leave our server, correct? So we join, and forever, we're sitting here. Where's our chat client? Read stuff in forever. We don't give you an option to quit. You have to hit Control-C, hit the terminal to get out of there. We're also listening for broadcast messages forever. So both of these things are happening forever. Clients don't leave. Well, if a client were to disconnect, what things would we want to have happen? If we gave the client some means of saying, I'm going to quit the server, maybe we have it be a special syntax. Maybe it's something like, slash quit, something like that. Maybe we have some special slash commands. I think something like Discord has slash commands, right? Like special commands that if you put a slash before it, it doesn't just broadcast that as a message. It treats that slash command and says, oh, you're trying to do something extra special. So since I just read in a slash quit, I'm going to go ahead and bail instead of broadcast that to everybody else, something like that. So assuming we added a slash quit command to our current code that allows a client to disconnect, what should actually happen when a client disconnects? Go ahead. So among disconnecting the client eventually, right, having the socket closed, maybe closing the print stream and the input streams, we need to remove, if we go into core, we want to remove that client that we added from our array list. Well, array lists, again, are not thread safe. And this is where a problem comes in for us. I could write another method here called remove client thread and make that guy synchronized, right? That way more than one client can't remove themselves at the identical time. But that does not prevent us from having another client add to that array list at the same time as we're removing from that array list. So imagine if you're any sort of collection data structure. Linked lists actually kind of are the easiest way to imagine this when we were originally writing linked lists in like 300. If you start removing multiple things from your linked list at the same time, or you start adding something at the same time as you're removing something, the idea of head, tail, and possibly the number of elements that are in your linked list might change in the middle of you adding something. That would be an example of not being thread safe. When you have multiple things trying to make changes at the same time to a data structure, that isn't going to do that well. So when we broadcast the message and I create this guy, which is a for each loop, this does not actually, I don't believe the for each loop in Java actually creates what's called an iterator. You can create an iterator from an array list. We're not going to do that yet, but I just want to make sure I'm giving you good information. So an array list is iterable. Yeah, we can ask it for an iterator over the elements in this list in the proper sequence. And an iterator so the iterator adds thread safety to this effectively. So it says an iterator allows the caller to remove elements from the underlying collection during the iteration. It's calling it well-defined semantics here because it depends on how you're going to actually end up using it. So the idea would be is right now, if I have a for loop that's going through all the elements in this, I doubt my for each loop is creating an iterator. If we want to promise it's not, we can say for int I equals 0, I is less than my array list dot size I plus plus, then grab each element from it. I might try to get from bucket 4 when there's no more bucket 4. Okay. More than likely what would happen is the bucket 4 right now is a different bucket 4 than it was a microsecond ago. And I then try to access bucket 17 when the last legal bucket is bucket 16, because the size of my array list has changed while I was going through it. An iterator gives you a snapshot of the current state of things. Sure, you might, in our example of removing something, you might use something, you might get a value from the array list that technically does not still exist, but you won't read from null. you will have that element because an iterator is kind of like this new instance. It's here's a bucket of what the current state of it is, and this guy is not directly linked to that. It might be that you're actually not getting direct pointers either, though. So changes you make to it might not change. It depends on how their iterators work. But in any case, I'm not expecting you to use iterators for this next thing, because right now we're accepting the fact that we might have some thread safety issues with our code. So we're just going to still keep with normal programming, because we're seeing that in general, race conditions are not something that are a major problem, but they're actually one of those things that are difficult to solve. Okay. And even though I've shown you with the synchronized method or synchronized keyword, we can protect, we call this the critical area, we can protect the number of threads that are actually accessing this particular method at one time to exactly one. That's good. But we don't have a way of synchronizing both an add client thread and a remove client thread under the same umbrella. Technically we could have a single method called do something with client threads and synchronize that, and you have to feed it a keyword, whether you want to add or remove. What are you doing? Then you could technically do it, but that's starting to become like you're kind of hacking the system, right? You're saying, look, I don't want either of these things to happen at the same time, so I'll just make one method that does both things depending on what parameter you send it, and I'll synchronize that method. So only one of those two things can happen at once, which then technically would support it. Go ahead.
Going down this hacking, if you would like to call like an add like helper method and a remove helper method within that class, would they still be synchronized? Or within that method?
If you made them private, yes. Okay. Because, well, the answer is yes, they would still be synchronized if it was in here, but you'd want to make sure that somebody else couldn't call them externally. And then you'd also want to make sure that nobody else inside your methods here that weren't synchronized were calling them. So you're kind of opening yourself up to, yes, we're technically only calling them under the conditions of being synchronized, but that doesn't control who else might have access to calling them. Okay. The homework, add the ability for our clients to /quit from the chat server, which removes them from the broadcast list and closes all of their connections. Put a noted here. You do not need to consider thread safety for this. I mean, we're walking in with the knowledge that under the right circumstances, probably not going to be, when you're, especially if you're testing it yourself, and even testing with a group this small, probably not going to be something you can even reproduce. But technically, we do have a problem where two people can get added at the same time and one of them's left off, or so you've connected, like what says I'm connected, but I'm not getting any messages. Well, it's because you lost the race, something like that. We're allowing that to be a problem currently. All right, questions, comments, concerns, bribes. All right, I will see everybody on Thursday. What?